Alright, so first let's start. We are going to develop this compiler in C because C is a simple language, and C is one of the most basic languages. So the eventual aim will be to develop a compiler for this language in this language itself, which is called bootstrapping. So if we develop this in C, the benefit will be to be easier to translate it into our own language. Alright, so we're going to do it in C. So main.c, and I'm not going to use any build system or any things like CMake or make or stuff like that because it's going to be a simple compiler, and I'm going to try to keep it in a single file for now. If it gets too big, we might separate it in separate files. But for now, let's just do it like this. So let's just have a simple program. Okay, so let's start with the hello world. We'll use GCC. Though I'm using Windows, we'll use GCC under WinGW. You can use Visual Studio with MSVC, but yeah, CLang is also good. You're not going to use many libraries. It's just simple standard library and basic C, alright? So no platform, it won't be platform dependent or stuff like that. So GCC main.c, and I named it Resort, just a new random name. Let's see. And we have our hello world. Now let's build on that. So first we need the arguments because the arguments, right? The compiler takes their arguments. In a GCC, it takes the main.c argument, right? So we do have that. Now one thing, our language is not going to one important thing I forgot to mention is normally you see in languages like Python you import modules, right? Import something, alright? In Python, in Java, import Java dot something, right? In C#, this is Python. This is Java, and this in C# you do using dot say zero, something like this. Alright, in C# you do something like this, but in C++ you do something like include. Alright, so you see, this is a way of including separating our program into several files. Now that is very important, you can have a huge file with a huge program, but sometimes it's convenient to split it up in several files. In our programming language, how are we planning to do this? Well, let's see. Import something is like you're exporting it as a separate module. That's complicated. Let's ignore it. This one is complicated, similar to Python. This one is similar. This is the simplest. How this works is this is just going to replace this line with the contents of that file. What do I mean? If you know C++, you should know this, right? This is something. It will open something.h. It will search for something.h in the include path. If it finds that, it will replace this entire thing with the contents of something.h. Otherwise, it will be having a syntax error, right? So we will have this too. Now, how do we include stuff? So it will be import, and the file name. Right? This is the file path. It will be imports the file path. This is path to file. Right? Now, this will be related to the input path. So, right. For now, let's see. We have to supply the input. We have to parse the arguments to get the input, right? So for now, we are not going to be concerned about several include paths into directories. Just the current the directory in which the program is running, the compiler is running, the current working directory will be the include directory. Alright. Later on, we can build on top of that and add an array of include directories and stuff like that. But yeah, that will be easy at that time. But let's not complicate stuff right now. First, your arguments. If argc not equals to 2, what do we need? We need 2 arguments. First is, let's say 3 arguments. First, if these 3 arguments are not there, it will be print usage. Now we just going to printf usage. There's a neat way to print the usage, right? So it will be zod space the input file and the output. Alright, let's keep it optional. If it is less than 3, if it's less than 2, if it's 1, right? Input file, and this is optional, the output file here. Now it's going to split up a exe executable in Windows and normal file in Mac, but let's just keep it for now. We are going to work on Windows for now. Let's just think of Windows, right? Exit failure. Right? Now we're done with this. Now let's have const pointer the input file. So what exactly is input file? Well, argv is the array containing the parameter, the command line arguments, right? So what are the command line arguments? The command line argument 0 will be zod. The command line argument 1 will be the input file, and if there is this output file, then it will be the command line argument 2, right? So it will be argv1. Now const pointer output file equals, let's say, initialize with the default value, say a.exe. Now this is the standard for GCC. Like for example, if you just compile a program in GCC without a output file specified, it will dump the file called and a.exe on Windows. So now here, if argc is greater than equals to 3, means third parameter is there. Let's say out file is equals to, what it will be equals to? It will be equals to argv2. Alright. Now we are assigning to a const variable. You might think it's questionable, but what this means is we cannot change the value pointed to by out file. But we can change the value of out file itself. Alright. Out file is pointing to this string. Alright. We cannot change. For example, we cannot say out file 0 equals to some character. We cannot do that. You can see it's an error because you see, expression must be modifiable L value, right? It's not possible. But we can change the value of out file itself. However, if we don't want to do that, what we can do is, let's say, we can write here with const here. What that will mean is you can't change the value of out file itself, but out file 0 equals to t. Now this seems to be valid. This is valid, right? So this is an interesting thing in C and C++ to keep in mind. Now, with this we have got our input file and output file. Let's just first read the input file and get the data, right? How can we read the input file and let's read the entire file, right? So let's do that. First, we need to open it, for example, file and let's say fd file descriptor. So descriptor means it's an internal handle that the operating system maintains. If we are calling a function to read the file, so it is internally calling some function depending upon your operating system, and that function is reading the file. The C function, like fopen, right? Fopen does not read the file. It calls some internal operating system function that reads the file. For example, in Windows, it will be opening some file handles and reading that. In Linux, it will be some syscalls and stuff. Alright, it's complicated stuff. In the C API, we can use fopen. So we have to provide the input file and we will read and read binary mode. So we are reading a text file, not just reading binary mode, right? But because every text file is also binary, right? A text file is a binary file, and binary is like, the binary code is alphanumeric, like 65 to 97, and 65 to something, and then 97 to 122, and then 48 to like this is alphanumeric. And also there is special characters. We don't have any binary data. The binary is not data. It's text. So we can just read text files as binary files also. It's not an issue. So first we need to get the size of the file, to allocate the memory to hold that data. So how do we get the size of the file? So we do fseek, fd the file descriptor, and then we have to seek to the end. Alright, so it's offset is 0, and we just seek to the end. We're going to the end now. Size will be the size of the file up here will be fl. Like where exactly are we? Like where exactly are we on the file? That will be fl. Right? We've got the size of the file. Now we need to reset the files in the current position. That like fseek and we can say seek set. Right? Now we can also do something like if I remember correctly, rewind something like was there. Rewind was there. Yeah, you can use rewind and fd. This too does the same thing as this fseek 0 set. But let's go with that. Now I have to read the entire file, So let's just allocate the memory. Character pointer buffer equals to malloc. Allocating the memory, and it will be size of file. Now you have to check. It is a good habit to check whether the file buffer has been allocated properly or not. Buffer equals to null. That means malloc failed due to some operating system issues. So you just need to printf malloc failure. Right now this is a good habit. Now return except failure. Right. I can also close the file. Right? FC always close. But you always close the file. Whenever you're opening a file, you have to close the file. Otherwise, there will be issues with the operating system. The file will be, we might get corrupted and all. Right. Now we have read the file. I have to clear allocated the memory and check whether the memory has been properly allocated or not. Now it's time to read. And read. Now how to read it? First, the parameter is the buffer. Now the size. Like, there are two ways. You can just do one. The size of a particular element is 1, and the total number of element count is the size of file. However, if you just want to read it totally, like a single element of size of file, and we are just reading one element, alright. And then we have to provide the file descriptor, and we have read the contents of the file into the buffer. Now we've got a buffer. Also have to check one thing, right? If fd equals to null, which means let's just copy paste this thing. This is occupied. Now fopen failed, return except failure. Now we've read the file in the buffer. Now we have to compile it. Also, since we are reading this as a string, so we need to allocate size of file plus 1 because we have to not terminate it. So and again after reading is done, buffer size of file, that is the last index, is equals to 0. This we have to not terminate it. Now one more thing I will do is plus 2, because in our program, like characters, let's see this one once. In our program, characters are parsed, things are parsed based on space. However, if the file ends without a space, this won't be parsed because we are going to parse whenever we are going to stop whenever a function, whenever a space is encountered, space. However, this is not going to be parsed. This is the end of that. So we're just going to artificially add a space at the end, right? With this, it's going to be a space. So it's ASCII of 32 or a space, and that's it. That's going to help in our parsing, in our lexing. First thing we need to do is now compile. How it's going to work? Let's see. Let's go along the way. Void compile. Let's do it. Now we just need to pass it to buffer. Character pointer, file data, input data, raw. This is the raw input data. Right. I'm just not going to pass it because I'm doing it globally because it's easier in that way, simpler, right? So input data raw equals to buffer. Just copy the pointer out here. Now we're just calling compile. In this compile, let's just test everything we have done until now is correct or not. So how to do that? Just printing if we have read the buffer correctly. Let's just assign it null for me. Alright. Input data raw. Also, we need to create a dummy file, alright? So we just need temp.serial. So let's just write the expression. Alright, this is a simple expression. Let's just keep it like this, and we just want to compile this again. Now there are some warnings. Because you see, this is typo again. These are multiple characters, so we cannot pass it in written single quotes. We have to pass it with double quotes. And the next one is that's fine. Sort. This to sort. It's going to print usage because we are doing wrong. Then if you pass the input file, say temp.sort, and it's printing the contents of the file. Alright. Now we have to find tokens. How are we going to do that? We're going to do lexing and parsing at the same time, because lexing the entire thing, creating a list of tokens, and then storing it in a different place, then again parsing it, again storing the parse result in a different place. That's all common. Like, why do you do that? You just lex and parse the lex token immediately. because our programming language is designed to be simple and manual. So let's do that. So first, let's say static int, or rather size key, because that's the convention for storing sizes. We need to compile it. So how to do that? First, we just going to say a new function void next character, or rather next token. Next token. What will next token do? Next token will give you the next token. Now there needs to be a buffer static, or rather let's keep it pointer buffer. Now this is going to be the next token buffer. We are going to push in the next token in there. How to do that? Right? File. Stop. Now next thing we need to do is we need to stop, like we need to skip the next white space before the next token is called again. Alright, how do we skip that? Same thing, just copy this thing and this up here. Now this time it will be while it is white space. All we need to do is increment this, right? And here just skip the white space. Also, why I'm telling it now it does not have to be 0? Well, because if it is 0, then that means you have encountered the end of the file. Alright. If return true if the parsing is finished, or rather if we are going to return true if there is a next token, there is a scope of having a next token. But if there isn't a scope of having a next token, means current token we have already reached the end of file. That means our parsing is done. Alright, and we are done with it. Now bool is not there because we have bool include std h, and that's okay. Now you can see it's alright, it's working. So now we can have tokens. Now let's try and print all the tokens. Now let's see an example with this one. Alright, so we have got this 45 example and this example. Let's just try and print the tokens. Let's do that. Whenever we are returning buffer. Whenever we are returning buffer index equals to 0, because we need to null terminate a string. That is important. Otherwise, a lot of functions, string functions, library functions will get stuck. It might crash up there, and even printf will print garbage in that case. Alright, we are done here. Let's just try and compile it. Again, warning. Okay, we don't have the use white space function. Okay, so let's create it. So \r is also. Well, if you don't know it, \r and \n. Well, in Linux systems, whenever you have a new line, that is a /n, whereas in Windows system, that is /n/r. In Visual Studio, you can see this is CRLF, that is /r/n. However, in Windows, in Linux, it is LF. You can change it with over here. Let's keep it like this. So you can see that. Let's compile without any issues. Well, let's you see, we've got our thing tokenized. Cool, right? Tokens. All the tokens are separated. Nice. We've got our tokens. See, so easy to tokenize. Our Lexing part is done. Lexing part is done. Lexer is done. See, just how many lines of code? 8 to 22. Next thing is, I have to parse it. Now parsing it, let's think of it what kind of data we're working with. What exactly are we going to parse? So we need to have scopes. Like this is a global scope. Then again, let's just write a proper function. Let's just write a proper program. Say our function's definition was like this. Let's write a program to print whether a number is a prime number or not. Our function goes like this: declaring a float variable. Now declaring variable is also there. How do we declare variable? Declare float like this. Okay. Declare double. The floats are not there. Declare value. This is not str, this is prime. Now true and false are automatically going to get converted into zeros and ones. So that's an issue. That's a simple trick. Now how we're going to do is prime is we're going to there are several versions of prime. For example, however, we are not going to implement this because this is small and we are not here to write efficient code. We are here to check our programming language. We are here to design a compiler. So let's see. Since this is going to be our prime function, let's translate it into our programming language. Value is there. Let's call it n. It's a naming convention. Alright, let's call it n. Okay, n. Rather not. Like, and one more thing. Whenever parameters are passed to a function, it is the duty of the function to pop them off. Right? This is popping off the parameters. That is the duty of the function. They call callee. The caller is going to push it. The callee is going to pop it off. Right? That's a convention. You are free to design your own conventions when you're writing programs in this language. Now we have to declare int text cv. Or let's do it. Since our programming language does not have any concept of new lines, this was correct syntax. Text cv. Count int 0, or rather count int, and declaring it to be 0 is 0. And that's done. Next, we have done that first line. The for loop. Now we are not going to, let's say again another variable let cv I equals to and I. Now we have declared the I. Now we have to loop. So let's just translate into while loop for now. Print I equals to 0. We're done. Again incrementing I, pushing I, one add, pulling I. Done. We're done. Okay. Next. Okay, we have to check whether if count 2 equals to then and return whether 2 well true return. True means we're pushing in true. Well it's false return and we're done. Alright, this is our isPrime function. This is our isPrime function in our programming language. Now let's just see the tokenized version of it. Alright, see tokenized. So nice. This is simple. This is simplicity. However, if you see properly, there is an error in our tokenizer. See, the last token is not being printed. The last token is not being printed by, yeah, this is going to be returning false in the last token. See, if you see the sort of code out here, its last token is supposed to be end. However, we're getting returned false and then none. That means we're not printing the last token. Right? The next token is generating that we're not printing it, because whenever we're returning end, we're also returning false up there, because also we're reaching the end of that. How to avoid that? And then off. Let's just change the condition not off equals to 0, and then buffer index equals to 0. Now we see we're getting the end of it. Now there is a next token if the buffer like the current character that is being pointed out is not a null termination character, as well as the buffer index is 0. I mean the size of the character selected is 0. Correct? So the next thing we have to do is parse it to make sense out of it. So we have got a function system. Let's see how we're going to parse it. Let's just think about it. We see we have got